The complement of an event E we'll denote with this E with that little tick mark. We'll read that as E prime, or you can just say E complement, is the collection of all outcomes in the sample space that are not in E. Okay. Just a quick comment on notation. The notation for the complement event has not really been standardized. So sometimes you'll see it as this E prime. Sometimes you'll see it as E with a little C up there for complement. Sometimes you'll see it with E and a line over it. So when we talk about probability, really any of these three notations could mean complement. And let me draw a picture here so we see it. Okay, in our sample space, this is our sample space, we've got an event E. Okay, E complement is everything outside of that area. So that's everything out here. Okay, and that gives us an idea of how we'll get our probability. The probability for our entire sample space is just 1, right? No matter what happens, it's going to be in our sample space. So if I want to get stuff outside of E, I'm going to do 1 minus the probability of what's in that event E. So 1 minus the probability of E. That's our complement rule, and sometimes it simplifies our work a lot. Let's look at an example. A manufacturer has determined that a machine averages 1 faulty unit for every 1,000 it produces. What is the probability that an order of 200 units will have 1 or more faulty units? Okay. So, the probability of 1 or more faulty units, 1 or more faulty, I'll just do 1 or more faulty. What this means is that we have not produced a perfect set of 200. Okay, so I'm going to say this is the same thing as the probability of not all good units. Okay, that's the same thing, right? 1 or more means that we didn't end up with all good units. And now that word not right there, that indicates to us that we can use a complement. This is going to be 1 minus the probability that they're all good units. And that is going to be a lot easier to compute than it would for the 1 or more, because 1 or more, that means that 1 faulty unit, or 2 faulty units, or 3 faulty units, all the way up through for 200. Okay, and that's a lot of work. So now we can do this probability. The probability that they're all good units, we look at what is happening here, and we know that our on average, okay, we get 1 faulty unit for every 1,000. In other words, the probability of a good unit, okay, when you produce 1 unit, the probability that it's good is 999 out of 1,000. Okay. Because out of 1,000, we expect 999 to be good on average. So the probability that all 200 units are good, okay, that means every single one needs to end up good. So that's going to be the probability of getting a good unit, but this has to happen 200 different times. So that's kind of like our independent events formula, right? The first is good, and the second is good, and the third is good, and the fourth, and so on. So we're going to take this and multiply by itself that many times. In other words, 999 over 1,000 raised to the 200. So that right there is the probability that all 200 of them are good, and then we do our 1 minus that in order to get our probability that we end up with 1 or more. So you can type this into your calculator and you end up with 0.1814, rounded there. That's the probability that we end up with 1 or more faulty units.